Okay, so our notes for today are 5.1. Our essential question is, how do I find the inverse of a function? Let's review what a function is again. Remember, a function is anything as long as the x isn't cheating, meaning an x can't have two different y values paired with it. Let's take a look at example A. Tell whether each relation is a function, write yes or no, and explain. So this first one, I noticed that -1 is paired up with 7. Then -1, the same number, is paired up with 8. And -1 is paired up with 9. In this definition, we would say that the x is cheating. So this is not a function. No, -1 is paired with 3 different numbers. In order for it to be a function, it has to just be paired with one number. Take a look at part B. I'm checking each of these, -5, -4, and -1. Since none of those repeat, there's no way for them to repeat with different numbers. So this is a yes. No x's repeat with different y's. All right, so if something is a function, x can't be cheating. All right, let's look at the next part. Now we're going to get into inverses. How do I find the inverse of a list of ordered pairs? So what we're going to do, ordered pairs come in the form x, y. And in order to do the inverse, we're just going to switch that to yx. You're not changing anything else. Don't change the signs. Just flip the order. So for our first example, given the function 2, 5, 3, 8, 4, 11, and 5, 14, the inverse is, and they put these nice little curly brackets there, so do your best to draw those. It's okay if you can't. Now we're just going to flip the x and the y. 3, 8 becomes 8, 3. 4, 11, switch it, 11, 4. 5, 14 becomes 14, 5. And then finish it up with a curly bracket at the end. And that's it. That's all you do. So flip your x and y, no sign changes. So you're not changing this from a negative to a positive or vice versa, just flipping the order. Example 2, same thing. Put your y first, put the x second. Switch them. And switch them. Same thing on example number 3. And what they've done here is they've just written a couple different ways of them asking you the same question, just to kind of see it written 3 different ways. All right, now we're going to focus on finding the inverse of an equation. So if you're actually given the full equation, what do we do? So there's 2 steps here. You're going to start by switching your x and y. After you switch your x and y, you're just going to solve for y. Sometimes solving for y is going to involve a lot of work. Sometimes it's going to involve just a little bit of work. It just depends on the problem. So we'll start by switching the x and the y. Nothing else moves. So a lot of people will want to take this 2 that's connected to the x and bring the 2 over here on the left-hand side of the x. That's not necessary. Everything stays. X becomes y, y becomes x. After you've switched them, you're going to solve. So start moving things away from the y. Divide by 2. And I'm going to go ahead and just divide the whole side by 2. That's going to leave me y equals, and I, for some reason, like to put that y equals first. It just looks a little neater to me. And that's it. That's the inverse. So y equals 2x plus 3, this right here, and this right here are inverses. So let's talk about what it means for something to be an inverse. Why is that important? What does it do? So what an inverse does, it almost creates a little loop. So it's like having a function. If you plug in a number to the inverse, it'll get you an answer. And then if you plug that answer back in, it'll get back to where you started. Let me show you an example. Let's choose any number. Let's just say we choose 10. X equals 10. We'll start by plugging in the 10 up here in our original equation. Y equals 2 times 10 plus 3. That get me y equals 20 plus 3, giving me y equals 23. So 10 got me an answer of 23. Here's what the inverse does. If we take this 23 and then plug it back into the inverse, 23 minus 3 over 2, watch what happens here. 23 minus 3 is 20. And 20 divided by 2 gets you 10. So 10 took you to 23. And then the inverse takes you back to 10. It creates this little loop there. And that will happen with any number. So you could pick any number you wanted to, and it'll still make that happen. Always getting back to where you started. All right, let's try a few more practice problems finding the inverse. Anytime you see f of x, that just means y. It's just written in a different notation. So because we're using x's and y's, the first thing I would do is just kind of write that instead as a y. Then we're going to switch our x and our y. X equals y squared minus 9. Remember, nothing else moves with it. The square does not follow it. And then your goal is to get the y by itself. I'll start by adding 9 to both sides. And to get rid of the square on the y, I'm going to square root both sides. The square root and the square cancel out. And again, I'm going to move that y equals to the beginning just because I like the way it looks. You can actually take the square root of x plus 9. So you just write it as the square root of x plus 9. And there's your inverse. That is the equation that if you plugged in a number would take you back to what you originally started with. Let's look at problem 6. All right, find f to the negative 1. So we are learning a lot about function notation, and f to the negative 1 is just function notation. That means inverse. It actually has nothing to do with exponents, and it has nothing to do with negatives. It's just their notation to mean inverse. So this is literally just saying find the inverse of this function. We'll start by taking f of x, changing it back to our letter y. And we'll start by switching the x with the y. All right, this problem looks a little bit strange. We've got some fractions here. Remember, fractions just mean division. So what I'm going to do is if I want to get rid of that y from underneath, I have to multiply by y plus 3. Because right now it's 2 divided by y plus 3. So I'll multiply to cancel. I'll do that same thing on the other side here. And I'll just put in a parenthesis for now. So over here I have y plus 3 in a parenthesis times the x equals 2. You have a couple different ways you can solve it. You could distribute the x, or you could divide the x to get the y a little bit closer by itself. Most people I've noticed distribute the x, so we'll go ahead and do that. Xy plus 3x equals 2. Then we could subtract 3x from both sides. Then we're very close to having y by itself. I just need to get rid of this x in front that's being multiplied. I'll get rid of that by dividing by x. I'll just go ahead and divide that whole thing by x. And there we go. That's my inverse. You might also see it written using the f to the negative 1 equals. That's the same thing, just a slightly different notation. All right, the last thing we're going to do is kind of just show what we did on that first page when we were talking about how to tell whether something is an inverse and what inverses do. So what we're going to do is we're just going to plug in two numbers just to make sure that they kind of circulate back to themselves like we did at the beginning. So how do I show that two functions are inverses? We want to start by picking any number. So when you pick a number, you get to choose the number. You can pick a hard number to use, like a big negative or a decimal to use, but I would advise picking easy numbers like 0, 1, and 2. So let's just pick something easy, x equals 1. I'm going to start by plugging it into here. I'm going to plug it into my f of x. So 2 times 1 plus 4. And you could put y equals in front if you want, or f of x equals in front. 2 times 1 is 2. 2 plus 4 is 6. What I'll do with that 6 then is plug that answer, whatever answer you got when you plugged it in, into the inverse. So I'm going to take the 6 and plug it in right here for the x. 1/2 times 6 minus 2. Half of 6 is 3. And 3 minus 2 is 1. Notice the 1, that's where we started. So 1 took us to 6. 6 took us back to 1. It literally reverses it or inverses it. And that works for any number. So let's say you pick x equals 5. All right, so we'll plug it into our function. 2 times 5 plus 4. 20 plus 4. Nope, that's definitely 10. Sorry about that. 10 plus 4. 10 plus 4 is 14. What do? We take the 14, plug it in right there. 1/2 times 14 minus 2. Half of 14 is 7, and 7 minus 2 is 5. Notice, we got back to where we started.